Okay, hello there and welcome to this course. The goal of this course is to help you add the MicroProfile Health Check API to your application. Now let's start by looking at what the MicroProfile Health Check API is. The Health Check API is essentially a way to help your application answer two questions. Are you alive? Are you ready to serve requests? Now, when would your application need to answer these questions? Take, for instance, your application deployed in a cluster managed by the Kubernetes automated management system. When something happens, or when your application is redeployed, or for any reason Kubernetes needs to spawn an instance of your application, it will need to check with the application if it is alive periodically and if it is ready to accept requests, so that request can be routed to the application. Now, the response that your application gives is what will determine whether the Kubernetes cluster, for instance, will route requests to your application. So the Health Check API essentially helps you, or helps your application, to answer the question, are you alive? Yes or no, up or down? Are you ready to service or answer requests or respond to requests? Yes, no. That's all the Health Check API is. So let's start off by looking at the Liveness Annotation. Now, the Liveness Annotation is used to check if your application is live or not. That's all it does. So to implement Health Check, you annotate a class with @application scope, as we've done here, because we want a single instance of this particular health check across the lifetime of the application. And the @application scope here is a CDI application, it's a CDI annotation that scopes a single instance of this particular class here for the entire duration that the application is deployed onto the server and it's alive, or it's running. So for the entire runtime of the application, there's going to be a single instance of the Liveness Health Checker. So the @application scope is necessary here. And then we annotate the class with the @liveness annotation. @liveness here is what tells the MicroProfile Health runtime to actually invoke this particular class here when there's a request for check-in, or there's a request to check the liveness of this particular application. Now, how does the MicroProfile runtime actually get the response? You need to implement the health check interface in your application and then override or implement the call method. This particular call method here returns a health check response object. Now, this health check response object is what contains the data to tell the client that is making the invocation to check for the liveness of your application, whether the application is up or down. And there are only two things that you need here: the name here and then the status here, up or down. Now, you can optionally pass in custom data to the health check response object. So in here we are just passing the status as alive, and we are passing some field here called time. So the time from which this particular class, this particular application was alive. We are instantiating this particular time field here in this particular outpost construct here. So we are saying that when this particular class is instantiated, and remember there's going to be a single instance of this. So when this is instantiated, keep track of that time and then return it as the time from which this application was alive. So to build the health check response, you simply use the builder object on it, and then you pass in the various values. In here we are saying the application is up, and then we are giving it a name, liveness check, with some custom data. We build and then we return. So when there is a request to the liveness or to check for the liveness of your application, the MicroProfile Health runtime is going to invoke this particular call on your implementation of the health check interface here, and then whatever value is returned here is going to be returned to the client. In this case, we are saying yes, the application is up and ready to, or the application, yes, it's up and ready. That's what this particular invocation is going to return. So that is what the liveness check is. Now you're wondering how you're going to have access to this. You are going to access the health check at the base of your application through the context path health. We are going to see through the resource path, not context path, through the resource path health. We're going to see that when we run this application and see make requests to this particular endpoint here. So the @liveness annotation here is simply returning this particular response here that yes, our application is up. That's what you need to do if you want to respond. You can also say the application is down and then you return a down response here. So again, just to recap quickly, to implement a check, in this case the liveness check, you just implement the health check interface, implement whatever logic you have in the call method, and then return a health check response object with either up or down as status and the name. That is for the liveness. Now for the readiness is the same as for the liveness, or the only difference is the annotation. For the readiness we have @readiness, for the liveness we have @liveness. The infrastructure and the construct are the same. You implement the health check interface here, and then you return a health check object here. Here we are calling this class Readiness Health Checker, which is also application scoped. Of course, we want a single instance of this checker as well. Now, the interesting thing is that in this particular class here, what we have done is to say that this particular response is down, or this particular object application is down. So we are returning the status as down here. So we are saying the health check response.named, we pass it a name, and then we set this to down. What this means is that a request for or to check for the readiness application will return an error, because we are saying that the application is not yet ready to service request. So for instance, if the request is made by a Kubernetes instance, the Kubernetes instance is going to skip this particular application, or skip routine responses to requests to this particular application, because in checking for the readiness of the application is saying no, it's down. So generally you would want to do some kind of custom logic in here to check if your database is up and everything is up and running, and then you return a status accordingly in some kind of boolean check, if else blah blah blah. You want to do that here, but for the purposes of brevity we are just manually returning a down response here. So in this case we have one response which is up, the other one is down. So we are saying the application, yes, it's alive, but no, it's not ready to accept request. So what are we going to get when we make a request? Let's look at that. Now we need to deploy the application, so I took the liberty to do that. Our application is deployed. Now let's go into our Insomnia client here and then make a request to the, let me just clear this particular history here. Now if you come into the Insomnia client, this is the base path for accessing the health of your application. Now this path here exposes the health check for all applications deployed to this particular server instance. So let's hit health and then check. Now you can see the response is 543, service unavailable. Now let's scrutinize the responses. We have, let's start down here. We have a liveness check with a status of up, and then we have a readiness check with a status of down. Now this particular readiness check is what is being returned to us in here, and this particular liveness check, liveness here, is what is being returned to us in here. So as you can see, the status here is down. As we rightfully set it in here, we say the status for the readiness is down, and that of the liveness here is up, and so you can see it here, status up. Now the aggregate effect of one of the readiness checks being down is that the service is unavailable. So in effect, we will need to have all the checks returning up for those to be green, which makes sense in the sense that if the application is not ready to accept requests, then obviously no request can be routed to the application. So the service is unavailable. Now, if the readiness here says it's up and then the liveness is down, it's still the same thing. The application is not live. It could be some initialization has not been completed, or for some reason the application thinks that it's not alive. So those will be down. You still have service unavailable. Now, to be able to route requests to those, you want to have all of these to be up, and then they should be green. So let's come in here. Let's change this to up. Let me just quickly redeploy this. Stop. Yes. Let's redeploy this again. And then this time around, we want to have both of these to be green, so that the service will be available and the request can be routed to this particular service. So this is how you can implement health check in your application. Again, in your logic here, in the core method here, generally you would want to do some kind of checking somewhere. Perhaps check if the database is up, perhaps check if some back-end resources available, some service you call outside of application is available. You want to do a series of checks you can do, whose responses or the result of those checks will determine whether you want this particular call to return as up or down, which makes sense because most applications generally will have a lot of dependencies on other services and other modules and all of those. You want to have all of those up and running so that you know for certain that your application is ready. There's absolutely no point in saying you are ready when you can't access a database or you can't access a critical service outside of your application. In that case, you'd want to say the application is down. So in the core method here, you'd want to do that kind of logic checking, and then the result of that checking will determine whether you want to return up or down. Now, application is deployed. Let's come back here again and then make another request again. So you can see once we return both as up here, we had a 200 response as okay, which means that all is well with our application. So then whoever it is or whatever cluster management system is being used can actually go on and route requests to our application. Now, in our implementation of the Metrics Health API, we used separate classes. You don't necessarily need to do that. We can have Composite Health Check. Now, Composite Health Check is where you have both the liveness and readiness annotations on one class. So essentially, the liveness and the readiness requests will all evoke the same core method. You can do that with a single class. So here we have a Composite Health Check here, annotated as usual with application scope that implements the health check API, and this particular class here is annotated with at liveness and at readiness, which means that whenever there is a request to the health endpoint, the health endpoint or the MicroProfile health check runtime is going to invoke this particular call method on the instance of this particular class for either of these checks. So instead of having two classes, you can also combine them into one. But generally, you would want to have two separate classes because we have two separate check types. And then you might have different logic in the various core methods of them, but you should know that you can also combine them to create a sort of composite health check. Now back into our Insomnia client here, we are making a request to the health endpoint. We can actually go further and say live. So we are making a request specifically to check for the liveness of the application. So you can see when we made a request to health/live here, we had a response here of up. We can also make the same thing for the ready endpoint, and then you should see the response for the readiness. So for all of those requests, again, instances of your implementation, your health check implementations are going to be invoked. Let's quickly recap what we've looked at so far. We've talked about the MicroProfile health check and said it's a way to automate your application to be able to respond to two simple questions. Are you alive? And are you ready to service requests? And to do that, we would need to implement a health check or the health check interface from the MicroProfile API in an application scoped class, because we want to have consistent data in a single class. We want to have one instance of the health checker for the entire duration of the application. So we have an application scoped class here that implements health check, and then we have our implementation here returning a health check response. And then we said you can have different classes to implement readiness and liveness checks, or you can have composite health checks. Now, apart from the composite health check, we can also have the health check producer. You can use CDI to produce the health check. So in here, we are manually implementing this. We can also use CDI to produce the health check object. Essentially, what the MicroProfile runtime does is that it needs an instance of the health check, so it can invoke the core method on it. What you're doing here, or what you can do with CDI, is to use the @producers annotation to create a health check. So in here we have @producers here. Let me just uncomment these so you can see it well. In here we have @producers, then we have @liveness, and then we just have a field or here that takes a lambda here and then returns a health check object. And then we have the same thing for the readiness. So this is another way you can implement the health check in your application. Now the final thing I want us to look at is the now deprecated health check. Before MicroProfile 3.2, there was this particular annotation here which you could use to get both a readiness and liveness check, but this particular annotation here has been deprecated. So now you are encouraged to use the liveness and then the readiness annotations. Before, this particular @health annotation would do the same thing that the two annotations do now, but this particular annotation here now has been deprecated as of version 2.0 of the MicroProfile spec. As of this particular version, this particular annotation has been deprecated, and you are encouraged to use the better meaning, liveness, and readiness annotations to implement health check. So this here is now deprecated. Before then, this here was doing the work of these two. Now you should use these semantic annotations to implement the health check in your application. So in effect, this is all the MicroProfile health check is. It helps you to automate your application such that, or implement your application in a way that it can autonomously respond to requests for these particular requests to this particular questions of are you alive and are you ready to accept requests. These are very important questions when you deploy application to the cloud and it's deployed into a cluster managed by cluster management systems like Kubernetes, they will generally want to find out the status of your application before routing requests to it, and your application should be able to help them by responding to these questions. So this is just about it with the MicroProfile Health API. There is a guide, a detailed guide on the Payara website that you are encouraged to download and peruse, which goes into great detail about the MicroProfile Health API that you can peruse to implement a robust application that can respond to these kind of requests. So check it out. The link to the guide is available in the description for this video. Check out the guide, download it, peruse it, and then you can implement better applications that can act well, that can be good citizens in a cloud native environment. Thank you for watching.